Hi, Mitch Wenger back with another video on data analytics and machine learning. In this video, we'll talk about baseline performance and how you can use it to help determine investments that you want to make in data. Hope you enjoy. Okay, let's get started. So far, we've focused mainly on evaluating a model or evaluating that model against other data mining models. We've alluded to baseline performance, but it's important to put some thought into what an appropriate baseline should be when you're evaluating model performance. Keep in mind, you'll need to demonstrate the value of your models and indeed your data mining efforts to your stakeholders. As with so many things in data science, the nature of the application will drive what you consider to be an appropriate baseline. Weather forecasting makes a good example. What are the most intuitive ways to predict what today's weather will be like? Lacking a radar map and sophisticated meteorological models, we can simply remember what the weather was like yesterday. This approach uses persistence to make a prediction. Alternatively, we can refer to a journal maybe that we've kept to determine what the weather has been on this date in previous years. This approach makes use of historical averages. When it comes to data science, we actually have several potential baselines we can use. First, we could use a completely random model, and this is a simple alternative that can give you a starting point. Next, we could use a majority classifier. This is a naive classifier, and we've talked about this already, that simply chooses the majority each time. This one can often be difficult to outperform, especially if your classes are highly unbalanced. That brings up a good point. Don't be surprised if your model, even a model built using one of our data mining algorithms, does simply predict the majority class. Of course, we now know better than to focus simply on maximizing overall accuracy. Now, beyond random or naive models, we have some other very basic models that we can use as benchmarks. A basic conditional model that simply uses the most informative feature can be used to create a decision tree stump or a single variable regression. You can also use a simple model using your domain knowledge. For example, a fraud investigation team believed that defrauded accounts would see sudden spikes in usage. A simple model that checked for such spikes ended up being quite effective. It's also important to compare different data sources to determine the value of each. What's the cost of acquisition for each data source? And does it provide appropriate value? So as you can see, there are a number of baselines or benchmarks, if you will, that we can consider when determining how to evaluate a model. As mentioned earlier, it's important to be mindful when considering what an appropriate baseline should look like for your problem. That's it for this discussion on baseline performance. I hope you found it useful. As always, be sure to check out the other videos in this series.